Okay, welcome back everyone. I think we'll get started. I'm very glad to see you all back for these afternoon sessions. The first session, I'm just going to introduce it. It's Johan from Mapbox who's going to talk about the state of OSRM, the OpenStreetMap routing machine. There you go.
Hey, I'm Johan. On the program it says the state of OSRM. That stands for the open source routing machine. I'm from a company called Mapbox. You might have heard about us. We do tiles and geocoding, and we do directions. We sell that as a service. All of our core components are open source. And one of these components is OSRM, which is a routing engine that routes on road networks, basically from A to B. The cool thing about OSRM is that it is extremely fast. So, first where you're going to know it from is if you go to OpenStreetMap.org and you want to do routing, then OSRM is the standard routing engine that you get. There's others that you can choose from as well, of course. We run a demo server for OSRM where it is deployed and running, and you can use it for free if you want to. We are running on the demo server basically the latest version of OSRM, so it breaks fairly often because it's also our integration and test system in a way. So this is what we get out of it. Yeah. So the really cool thing about OSRM, why you should care about it, is the fact that it's extremely fast in routing. So this is an example. If you go to map.projectosrm.org and you start pulling around on the icons, then yeah, it will just route extremely fast. We route usually within tens of milliseconds, and then there is network latency around that as well, which sometimes it might feel a bit slower. The major parts of creating these routes is that we have a pre-processing step first, which can take quite a long time. So it can take between 8 and 9 hours for car routing, and it can take up to 24 hours for walk routing. But in the pre-processing step, we basically process the whole planet and save it in a way that we can then do these extremely fast routing requests against it. So OSRM has existed for a couple of years now, and about a year ago we set out and asked ourselves, like, what's the next things we want to do in OSRM? And we figured out, okay, we need to get ready for doing routing in the car. Other companies are already doing this. You might have seen Scobler and Telenav, who are doing a great job on this. Navme is doing a great job on this. We want to do a great job on this as well. So yeah, Mapbox is just doing a me too here as well. So in-car navigation, there's basically two big, when we say in-car navigation, what do we mean? We mean something like this. So being able to do routing wherever the user or the client wants to do that. This can be in your app, this can be on Android, or this can be in iOS, or this can be in an embedded system that runs, for example, in the instrument cluster of your car. And the routing experience should include all the things that make routing great. So it should be great routes that match the real world. It should include all the roads that are in the real world. It should include them like up to date. It should have distances, and it should have times. It should announce to you voice instructions. It should have text instructions. It should have turn symbols. the posted speed limit could be totally different. So in Berlin, there are certain roads where you can go 70 kilometers per hour, even though it's residential, or it's actually then it's like secondary. But and the same way, there's a lot of parts of the highway where you can only go 80 because they're in the city, for example. So that's the posted speed limit. The posted speed limit does not always correlate with the actual speed that cars are going. There is the usual case is a lot of cars go faster than the posted speed limit. So that is kind of becomes a moral question if that should be represented in the routing engine or not. The other thing that is way more common is that you will never be able to achieve that speed on that route. So there's always traffic on this one street in Berlin, and you will never go 50 there. So that's all the things that are static. That means static, when I say static, I mean that's the things that you have one value for all of time attached to a certain segment. There's a lot of things you cannot represent with this. Specifically rush hour. Rush hour is a thing that happens and you wanna model it in some way. So you need dynamic values here. And the one way to model this is to have basically historical dynamic speed data, which means that you usually you segment a week, a typical week, into small chunks. So you say every 5-minute segment or 10-minute segment or 15-minute segment, there's one speed that people can usually go there on the street. And this can incorporate rush hour. So you will usually see in the morning it's slower, and then it goes fast again, and then in the afternoon or evening there's a second rush hour, and it's going to be slower again. The thing you cannot model with these dynamic speeds, with the historical speeds, is things that divert from a regular week. So an example here is holidays, sports events, weather, construction work, incidents, accidents, all of these things that don't always happen, but sometimes. So in that case, what you want to do is you want to have kind of a real-time speed engine that can take all of these inputs together and derive what is the current speed right there. The big problem with all of these things that I'm telling you here is that most of this data is proprietary. Please talk to me if you want it to be open. Tell me your use cases. I'm interested in this. Given that you have this speed data from whatever source that is, the way how we load this into OSRM is by having it as a CSV file that basically says from node and to node, and then has a speed value attached to it. And in this way, you can basically cover the complete roads network in OSM. And here's one example. So this is going from the Mapbox San Francisco office to the airport. And in the morning, you can basically see there's the rush hour. So this is the ETA. The yellow or, well, orange, the upper one, the upper graph, goes basically from the morning to midday. And you can see how in the morning there's the rush hour and the ETA is growing. It takes longer to get to your destination. As a comparison, there's the flat blue line, which is basically without traffic. There's just one value. It just stays the same. The other thing is sometimes it's better to take the freeway than to take or go through the city. So this is modeled here. You take different routes at different parts of the time of the day. Okay, so that was speeds. Assuming that you did all the speeds modeling correctly and it's loading fast into OSRM, you get great ETAs and you get good routes and this looks fine. So users will be happy with that. The next question is, what else do they need? Of course, first they need to have the routing response on their device, in their car. If they have a mobile phone and it's in their SDK, it's easy. You do a request. If it's built into the car needs to have connectivity to mobile to reach the servers, can get the route. Any case, you have a route response now. Now you have to turn it into an actionable representation for the user. And this is where guidance comes into play. So when we set out to think about guidance more, we realized that it's like really hard to code in a car. And what we need is we need a tool to do basically armchair testing of our assumptions and of our routing engine and of our response. So what we built is a simulator that can run in the browser. This is open source. It's called Guidance Sim. You can find it on the Mapbox GitHub account. I'll post links in the end. But the important thing is it includes all the things that you would need from a guidance experience. So it includes the text instructions, how much time you still have. It does include voice, which I don't have on here right now, because you never know if there's going to be audio in a presentation. And it also includes on the right basically the raw response, so we can debug this way easier. And you can go back and forth as well. This is also sped up. So when you think about a response that you get back that you want to route on and do the routing from, it's basically an array of objects where every object represents one moment, one maneuver, where the user has to make a decision. So the first decision could be, like an easy decision is like, you should start. Like that would usually be the first one. You should depart in whatever direction. And then usually what you get is turns. So turn left, turn right. All of these objects, these step objects, include a lot of data that the client can then use to build an experience. So they include, what's the street name you turn on? What's the destination signs that are for that? What's the lane configuration? What's the shape of the intersection where you turn? What is the actual turn type? What's the direction of that turn? So all of these things are returned in the routing response. So what we realized fairly fast is that on the left is our old instruction types, so the types that every of these steps could have. Depart, continue, turn, roundabout, and arrive. And we realized this is not sufficient enough to provide a good routing experience, so we added a bunch of new types. The important ones here, so new name and end road are ones that help with name changes, and so new name helps with name changes. The route that you're on stays the same one, but it gets a different name now, and you want to be informed about that. End of the road can be used for turns, where instead of saying in 200 meters, turn right, you can say at the end of the road, turn right. We then worked a lot on highway and motorway instructions and guidance, which we introduced the fork and merge operators, as well as ramp operators and lane operators. I'm going to explain these more in a bit. And roundabouts are actually really hard. Everyone who ever mapped a roundabout in OSM knows that it's a weird thing to map. It's an even weirder thing to route on. It's really hard. So we basically introduced the rotary, which is a turn type, which is a type within OSM already, and the roundabout turn, which I'll explain later again. But which basically is a very we don't tell you to go into the roundabout. We just tell you at the roundabout do a turn. So we added all of these new types that would give us better expressiveness in the guidance experience. As I mentioned, motorways were a big issue for us. This is really. Can I zoom in? Yes. Okay. So this is the old way of how OSRM version 4 would represent a ramp. It would just say continue, because it would look at the turn angle and say, well, when you go down a ramp, it's just a turn, 10-degree turn. That obviously didn't really cut it. It's really bad. This made OSRM version 4 unusable for doing any sort of real routing. Obviously, this is better now. We now say take the ramp. In this example, there was sadly no destinations in there, but it should say take the ramp towards, I don't know where this even is, towards Berlin. So ramps are represented now better. We added destinations as well. So is this big enough? Yes, this looks better. So we can now say you get on the Autobahn and you want to take the ramp in the direction, for example, in this case, towards Brussels. And for anyone who ever mapped destination signs, so first of all, this is how they look. it's a destination sign. It says Brussels. And in this specific case, it's mapped as the destination is Brussels. Actually, in this case, there's two destinations here. So there's Brussels and Luik. And at the moment, we return all of these to the client. And the client can then decide how they want to deal with this. One example that we use is the text instruction. So the thing that is announced as voice to the user is only the first destination, so it will only be Brussels. But if you have a representation on the display, you could display the whole destination sign. Next thing we integrated is lanes. So basically when you do a turn, you need to figure out which lane you need to be on, which lane is the right one. This helps tremendously when specifically routing on motorways and highways. This is how lanes look. So here the configuration is there's one straight, there's another one straight, and then there's one to the right. In OSM, this is mapped with turn lanes key, and this one is actually mapped as none, none, and right. The important thing, maybe a difference here with destination versus lanes is destinations you do on the way that is leading away from the route. So it's basically behind the intersection that you want to do the turn on. Whereas lanes are on the segment that is in front of the intersection. We combine all this into one step where then the client can build a response for the user. This is an interesting case where actually the way you model it, you model the data is fairly different to how we return it, because the intersection itself and the turn itself is not enough to give good guidance. You need to look at more segments. There's also some advanced things we do there for combining lanes, for combining turns, so that we reduce the number of instructions that we send to the user. If anyone wants to hear more about this, then we can probably give an advanced talk at some point. Next thing, roundabouts, already mentioned, pretty bad. We used to only say enter the roundabout and take the exit onto the street name, which is like most roundabouts don't tell you the street names on big signs. So it's like basically impossible to use. Whereas now we say take the second exit, which is way better. Still with a lot of roundabouts, you don't want to count exits, especially if they're really small. So we introduced the roundabout turn, which only says at the roundabout, turn left, which is way better. One thing that is really annoying with a lot of, becomes easily annoying when you do guidance is that the user is just bombarded with instructions that are not valid anymore the moment that they actually have to do something. A case here is, for example, doing 2 left turns instead of a U-turn. So you get do a left turn and then immediately you get do a left turn again, which means you just get constant voice feedback from your routing engine, which you don't want. Instead, it's way easier to say just make a U-turn, and this is shorter and concise. Our goal definitely is to give the user as least instructions as possible, but still guide them to their goal. I already mentioned text instructions. So one thing where OSRM is differing from a lot of other routing engines is that we don't actually include text instructions in the routing response, which we do for the reason that we want to give the users the total control over how the actual text instructions should work, how they should be compiled. So it's a standalone library that you can basically put on top of OSRM, but you can also run in the client. So it can run on the server or it can run on the client. And in these text instructions, what we do is it's basically defined as a big JSON object where you can define all the strings in there. It's basically taking the step object and then it's 100 lines of code that turn this into a text instruction with all the special cases that exist. If you don't like a roundabout turn, then you can just basically remove it and just change it to a different text instruction that fits your case better. Also, this opens up the avenue for translations, which we'll hopefully have soon because we didn't get around to it yet. One last thing, with everything that is guidance, basically, and this also applies to OSM, what we try is to find like general rules for the world, right? Like we try to model the world. This is worth a picture. Great. There's a link to the original video afterwards, so you can watch it all the time. So what we try to find is rules for the world, how we can model the world. And as you all know, like there's different ways in the world how things are mapped. Like local communities of OSM are different for every country. And what we struggle with in providing routing on that is that we have to find generalized rules for all of these cases. What we try to do now is we try to do some of these decisions, but also give these decisions, make them customizable so users can change them again and customize them, localize them to their own user base. This is where OSRM is right now. Okay, thanks. You can try it out today. Go to map.projectosrm.org. You can play around with it. You can see your destination signs and your lanes that you mapped. If you are interested in in-car navigation, OSRM is right for you. You can bring your own speeds if you run it yourself. And I'm here, talk to me. Two things more to plug. One, on Sunday there's going to be, on Sunday there's going to be a workshop for making OpenStreetMap navigation ready, which is going to go into more depth with lanes and with destinations and turn restrictions. And the other thing is I would like to organize a Birds of Feathers session tomorrow. If if more people are interested in navigation, let's do that together. Okay, thank you.
All right, awesome. Super interesting combination of some high-tech algorithms and some core user experience here. Any questions for Johan or OSRM in general? Can we pass the mic around, please? Mic man? Thank you.
How do you handle historic data with different IDs than the current OSM network has?
We don't. We process often enough so that the state IDs are not a problem.
Because I was asking because if I have my own historic data set, how do I feed it to OSRM?
So basically what you have to do is you have to know, so when you get your data, usually you have either already IDs to it. If you like buy it from another vendor, you could, for example, have OSM IDs already in there. Then it's fairly easy because the IDs are already there. But you're going to have ID rot over time, basically. Like as OpenStreetMap changes, nodes get removed, new nodes are added, geometries change, all of these things. So you're going to potentially get wrong results. If you stay with the base map that you used, so the extract at a certain point when the speeds data was generated, then that's not a problem. If you want to update that data, you basically need to have your speed data in a format that is georeferenceable. So, for example, what you would do is you would save the geometries. One format that is very widely used in the industry is OpenLR, which basically is like a very compressed geometry, and you have to map match that to the roads network where you want to apply the speeds. You would have to do this every time that you want to update your base map.
The new evolution takes historical data. What about real-time data? If you add a source of traffic jam, events, and things like that, I'm building such a source, open. There's a session tomorrow about that. Do you have a way to use it for the moment, or is it something you plan but you have not implemented because you have no source of data?
Mm-hmm. So what we don't have is, we cannot directly ingest incident data, accident data. What you would have to do is you would have to apply that basically before when you compile the speed data that you have. and then feed that into OSRM afterwards. So it's basically a pre-processing step to the routing itself. We currently don't have any open source components on that we can share.
Yeah, because the problem is that you have to update your graph, but it's something you are not doing real time. So do you have any idea of how to improve OSRM if you add such a data source to
So OSRM is using an algorithm called contraction hierarchies, which needs pre-processing before. As I already mentioned, pre-processing can take quite a long time. We built a lot of ways to make pre-processing really fast, and internally we are down to like single-digit minutes now for certain geographical areas where we want to be fast. So this is how we speed it up, and in that way, like real time, like what does real time mean? It means that it's okay if the result is within a certain bound, so you have to define what's the bound. Is the bound like 10 minutes, or is it 5 minutes, or is it 1 second? If it's within minutes, we can deal with it by pre-processing really fast and loading it into memory fast. The downside of using contraction hierarchies is that you cannot update the graph once it's created, because mathematically it will not return correct results anymore.
Right, we have time for one more short question, but I'm just going to ask if the next speaker is present.
Do you have alternative routes?
Just a second. I'm just going to check first if the next speaker is present. Yeah, could you get yourself set up, please, with our technical assistant? Awesome, perfect. Okay, go ahead.
Alternative routes.
Yeah, the question is, do we have alternative routes? We have one alternative route, yes. Sometimes.
That was a very short answer. Okay, in the interest of time, I'm going to conclude this so we can applaud Johan once more.